Okay, so we have an actor on our world, a critter, and again, that this is inherits all of the actions and the functionality of an actor, and then we can redefine some of those actions and build them together to create new actions and create new crazy new things. And some of the things that we can create is actually really rather remarkable. So what I've done here is again, these guys just bounce back and forth, all right? So it's the same critter. Notice that I've got two objects in my world and there's one critter class, all right? So this is how I make a thing. These are the things themselves. So these are the objects. This is the class that defines how a critter should act, behave, and the functionality of that. Same thing with my world, all right? So I only have one world. Um, and there is an inheritance that's going on. The other thing that we haven't really talked much about is the idea of private data. So these are individual objects that exist in this world, but they've got data that is specific to themselves. They have an X and they have a Y. All right. So these are just things that have been created and they're stored in memory. And there's just a little picture. And then we're going to display that picture at a certain point and move that picture along. And that's what gives us the visual of the turtle moving from one side of the screen from the world to the other. Um, so what I've done is I've just added some code here that when it moves, if it is at the edge, it's going to flip 180 degrees. I'm just going to output a couple of things. This toString is going to output just basically its memory location. It's the class it's a critter, and where is that in RAM? All right. So that's how this toString, the toString of an object works. All right, I can redefine that to output something else, the number of lives or whatever I want to display. But the 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 basic thing that an object can do is output what kind of a class is it, where is it in memory. The other thing that it's going to do is it's going to output its x coordinate. So it's just bouncing back and forth, and it's either going to be bouncing on the left edge. If it's bouncing here, it's x. This should be something either 0 or close to it. Same thing in terms of if it bounces on the right edge. So I have a 600 by 400 grid world. If it gets to this edge here, it's going to either be 600 or it's going to be something close to it. So I want to run that, and that I'm outputting this to the terminal window. And so there they go, and they bounce. You're seeing right here, I'm going to clear the screen here. So every time that they bounce, here's what's happening. You can see the 0 and the 159, the 599, sorry, that is being displayed there. The other thing that you're seeing is that this is the memory location of the critter that was going 0. I've forgotten which one it is. So I take it back. This one just bounced off this edge, so that is at position at 28014A3C, whatever that means. So that's some location in memory, and this is what its x coordinate happens to be. The reason that I want to point that out is if I move this guy close to this edge, again, he's going to output, and again, same guy, same memory location, different x, right? So each one of these guys has its own x value. It has its own personal x location, it has its own personal y as well. It has its own personal which direction am I pointing. There are a number of, of pieces of data that is specific to this critter. I can create more data points that I want to keep track of, but the raw things, once it's in a world, I can output what its x and what its y happens to be. So here, again, they're just going to move along, and so this guy just bounced. All right, I'm going to move him again over here. He's going to bounce again, and now I'm going to pause him. And what I want to do now is I'm going to replace him. All right, so if I right click on him, I can delete him. I'm going to make a new critter, and I'm going to stick him really close to this edge. Notice what happens then. Now he is a critter, so he's going to keep moving until he touches an edge, and when he does, he's going to output its memory location, the class and the memory location, and it's going to output its x-coordinate. So its x-coordinate happens to be the same, but notice this. Notice that its memory location is different, right? So there were two. One was 280, whatever that is, and 614 and some change. This is neither of those. So each critter that gets created is going to have his own memory location. If I kind of line all these guys up, make another one and another one. So there should be a whole bunch of them, and they're all going to bounce pretty close to the same size. Maybe we'll just even delete him out. So when they all run, kaboom. Right, so they all go at the same time. Notice that these are all different memory locations because these are 4 separate objects that exist. All right. So again, the important thing to note is once they're in a world, it's got an X, it's got a Y, it's got a direction. 0, by the way, is pointing to the right. I believe 90 is pointing straight up. 270 is pointing straight down. All right. Okay. So now what I'm going to do is, here's my world, and I'm going to create another object. A critter bounces back and forth, and I think what I'll do is this will just be a whole new subclass that I create. And so I'll do, yeah, I think I did a little turtle guy. I need a name. This will be a box critter. Now there's a box critter, and I'm going to plop him in the world. Well, actually, I probably need to change my code a little bit. So just as there is there's an X and a Y that is specific to each actor, I can define my own data points that I want this thing to keep track of as well. So after I declare my box critter, I'm going to create a couple of data points. So one, this is going to be private. So each guy is going to have his own, just as each one had its own X. This is going to be a private int, and I'm going to call this step counter. So every time he moves, it is going to will keep track of how many steps has he actually gone. I'm going to create another private int, and this is side size. So how big is this guy? Notice that in this case, I am declaring just says I need some memory, allocate some memory for that, but there's no data that is actually in that. So I want to assign a value, and the way that I do that is I call something called the constructor. So in order to make a box critter, before we created a new object and we called the new operator. We didn't have to define anything, and that was it getting inherited from the actor class. There's a constructor there. So in BoxCritter, though, I want it to set these variables that I just created. I want to set them to a specific value. So BoxCritter, open and close, and we'll do this. All right. So this is a constructor. Looks like a method, acts like a method, smells like a method, is not a method. All right, so this is a constructor. The only time that this gets called is whenever the new operator is made. We don't, once an object is made, we don't recall that its constructor. So I might say, well, the step counter, that's how many times has he stepped. When he's first made, he has not stepped at all. So I'll say this dot step counter is going to equal 0. All right, so I'm going to assign 0 to step counter. All right, and that hopefully makes some sense because he hasn't stepped yet. All right, so I haven't clicked on act, I haven't clicked on run. The box size, how big a square box am I making here? So this is going to be one that I'm going to assign this dot side size equal moving what, 3. So let's say box size is 15. We'll see what that looks like. Could be really tiny. Now when he acts, so when he acts, it's gonna be this dot move 3. And I also want to, so he just moved, so his step counter should go up. So this dot step counter dot is going to go up by 1. It's step counter plus 1. And there are multiple ways to increment the old school way. We'll keep it with that. So keep on acting. Every time you act, add 1 to your step counter. But now, if step counter equals side size, I want him to turn. So I'm going to do an if statement here. If step counter, this dot step counter, small s, this equals this dot side size reached end of box. Then I want him to do something else. That should be curly brace. And this should be tabbed over. So this is where, again, making it pretty is really going to be helpful. All right, so what should happen if step counter and equals size? So he's gone along and I've reached 15. Now I want him to turn. So I'm going to call this dot turn. And I'm going to have him turn 90 degrees. I believe it's clockwise that he turns. I can change that if I want him to go spin the other way. Now, if I ran this code, there's going to be a slight bug to it. All right, so he is going to turn, but there is going to be a problem. I'll compile it. I don't know why this guy's kind of floating out here. That seems happy. That's good. And come back over here, and I'll add my BoxCritter to the world. There he goes, and there he goes, and he turns. But he doesn't turn again, right? So he went forward for a little while, and that got to 15, and then he should have turned multiple times, and that's not the case. Why is that? It's because if I were to output system out, print line, this dot step counter, I'll notice that it's getting to 15 and it's all going good, but it's going to continue to go up. In other words, I'm not resetting that at all. Right click, new BoxCritter. There he is, and he acts a couple times, and hopefully there is this. I had this clear screen up method call, but it's not doing it, so that's getting kind of annoying. So he keeps on walking. There's 3, 4, 5, 6, 7, 8, 9. Everything's going great. So now he's going to turn. He's at 15. Dink, and he turned. That looks great. But instead of resetting, that step counter back to 0, it continues to go up, which means that this if statement will never be reached again. So in addition to turning, I want to reset my step counter. Right? So I'm going to assign it back to 0. All right, there are multiple ways of solving this problem. If you're familiar with modulus, you might see a way of doing that. So here we go again. There's my screen. It'd be really nice if you cleared the screen every time that I ran it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. Turn. Great. Again, he turned and, oh, that's great. So he's already, it's at 0. Keeps going. Get 14. Turn. And I got me a guy who goes in a box. All right. That big value, by the way, that's when the turtle hit the edge. So I could add multiple turtles, box critters. I'm just not going to know which one they are. In fact, maybe I'll delete these guys for a second, and we'll restart it. And now we'll add one. I'm going to have him act a little bit. And then here's another one. All right, now he has not acted yet. Again, when I right click, I chose a new box critter. That is the call to the constructor for this class. So it gets its own step counter, its own box size, initializes them to the right value. And now when he acts, there's going to be a couple of them. So this that's up to 13. Well, that's the first guy that I had. 1, that's the second turtle, and it's toggling back and forth. So both of them are acting. This guy got to 14, and then he turned. This guy's still at 6, so they're kind of close. And anyway, you get the general idea. So the important thing to note here is that each critter has its own variables that define it. All right. If the standard first project that computer science students get is make a bank account. So there's one bank account class, but there can be many objects of that bank account. All right, and each one has a different balance. It has a different username. It has a different account number. So it's not as though the data for each object is the same. Each one can have its own independent data. All right. So there you go. That's how you make a box critter. All I have to do is figure out how to stop it.